another new feature in the 11.4 Infiniium software release. That's the ability to do noise compensation on saved waveforms. So increasingly, as eyes become more and more closed, it's important to compensate for the noise and or jitter introduced by your oscilloscope. And traditionally, we do that on a live waveform. So here you see a live 25 gigabit per second waveform with a fair amount of RJ and PJ on it. But we want to make sure that we're measuring just the DUT and try to compensate for the noise contribution of the scope as much as possible. To do that, we go into the jitter noise diagram, into the advanced tab, and remove to the remove or specify noise tab here. And we're going to calibrate the scope noise jitter, and it's going to tell us to disconnect the signal. It's easy for me, just turn off my generator. Let it determine the amount of noise that the scope is connecting. Turn my generator back on, run the scope again. Okay, so now let's clear the data, start over again. And one of the things reported in our jitter statistics down here is the RJ contributed by the scope that is compensated for. So that's around 160 femtoseconds. So what about the case though, if I stop here, that where I've saved this off as a waveform. So I'm going to open up, just to save time, open up a composite here that has the waveform loaded into memory 1. And I'll get a very similar analysis. Okay, here comes up my waveform memory analysis on a fairly warm waveform. Again, very similar analysis, but the scope jitter composition is missing, and I used to not be able to do that. So now, though, with 11.4, you go into the jitter noise tab, you go into the remove specify noise, and even on memory 1, you can go to manual and say, I want to have it remove that 160 femtoseconds of noise. And now, I've had to write it down and copy it in here. So I have to keep track, right, of how much noise I want to remove. But then I get a very, very similar analysis, identical numbers to when I was doing it live on the scope. And here now the scope RJ removed is 160 femtoseconds.